Okay, now we're going through a little bit more about how heat energy and water's ability to hold heat, to store it and then release it, helps drive what goes on our planet. Now, most of us would have seen this nice picture before, and I got this from NASA, and it shows the stages in the water cycle. And it's got lots of words there which we'll be going through on the way through, some of which we won't touch, but let's just say that all this is it's all about thermal energy, and all this comes from the sun, of course, and the effect on this depends upon how much thermal energy we actually have. So if we increase the thermal energy, then what it will do is will have an effect on this whole process. But let's look at the basics to start with. Right. We know that each day infrared or heat or thermal energy comes from the sun. And we've already seen that about half of it reaches the Earth's surface and interacts with the ground and the water. All right, so this drives this whole process. And it causes the change of phase of water, and that's incredibly important because we've already seen that water has a pretty high heat capacity or specific heat content, and we need to provide 4186 joules for every kilo of water. And we've already seen that to raise the temperature of our oceans, it's very, very high. We need a whole lot of, a yotta, one might say, of energy. And what we're doing now is we're moving the heat energy around our environment. So I want you to think not only of water changing phase, but I want you to think about this as basically heat moving from one area of our environment to the other. So we can have between the oceans and the atmosphere, the oceans and the land, the atmosphere and the land. So these three areas, and of course the biosphere. Bio is living things. So the living part of our environment as well. Let's break it down to basics. Now we know this is happening, so let's make some chemical expressions or some energy expressions as we did earlier in the year. Now the top one shows us what goes on in terms of if we've got solid water or ice, or if we've got any solid, and we change it to a liquid, then we must put in heat. So heat is an input. Right? So the chemical absorbs the heat and energy goes into that matter and is stored in it, if you like. Now the reverse applies for when we do notice I've just reversed these reactions. Instead of liquid being up here a product or an output, it is an input here. So I've got liquid and I change it to a solid, or in other words we're freezing something. Heat is an output, heat comes out. So heat's released. Now it's sort of counterintuitive that. Anyway, let's keep going. Please accept this. If we go to other types of changes, and that's why I've given this whole lot. Now let's have a look at liquids to gases. The same thing applies. We go liquid, heat is an input, so gases have more energy. Now this is probably pretty basic because we know that gases we form a gas at a higher or a temperature above the boiling point. And as soon as I mentioned temperature, we should remember that temperature is a measure of the kinetic energy of the particles. So I'm adding kinetic energy to the particles here. Now the reverse applies when a gas changes into a liquid or we get condensation occurring and heat is released. Now this becomes super important when we come back to these equations we had before in terms of the water cycle. Now there is one more type of reaction that occurs, and it does happen in nature as well, and this is called sublimation or subliming. When a solid does not form a liquid when we heat it, it goes straight to a gas, and the gas goes straight to a solid, no liquid. There is no liquid phase at all. So sometimes when we do this, or probably the best known example we've got is carbon dioxide or dry ice. Dry ice, if we heat it, simply becomes carbon dioxide gas. It doesn't become carbon dioxide liquid. It doesn't happen. But the same principles apply about energy entering and leaving. Now, when we sort of think about this, we're thinking about water. So let's go on to water. Let's be specific now. Water. So if we do this, we've got changing with heat changes to water vapour. Now this is probably one of the prime examples of what goes on in terms of the water cycle. So we've got evaporation occurring. Over here we can see we've got the oceans or any water body, and we've got evaporation going. Now we've also spent time with plants, and we know that plants lose water in the form of water vapour. And we call it transpiration. So what we're effectively doing here is we're storing water. So every time we're storing energy, heat energy. So every time water evaporates from the ocean, or every time water transpires out of a plant, we're storing energy in the form of water vapour. So water vapour becomes an energy storage. Now, as we can see up here, we can see that water can then be condensed so that energy is released back into the air or released back into our environment. When we actually form rain, we can actually see that this expression would happen, and we'd have heat being released. So it is really, really important for us to think about this. So the sun's energy comes in, hits the water. The energy causes evaporation to occur. Evaporation means that that energy that came in is now stored in the water vapour. Whoa, that's pretty tricky. And then it goes around the air and it circulates through the atmosphere, and of course we know we have rain forming, so we have the reverse happening, so condensation. So then some of the energy is released back into the air. Now this becomes really important in terms of storms. The amount of water vapour, if we've got a lot of water vapour being stored, there's an awful lot of energy involved in it. And this is why we have things like here in Hong Kong, we have our typhoons, and a lot of the typhoons are resulting from this water being very, very hot, and that means more evaporation occurring. Now, if more evaporation occurring, when it does finally cool down and release energy, that energy comes out in mechanical forms of wind, but we end up getting lots and lots of wind, and we get lots and lots of rain. So some of our energy that originally came from the sun and was stored in the air by water vapour is released, and when it's released it is very, very harmful. So we've got to think of these sort of things happening. The water cycle is actually showing us how the sun and the simple thing of our surface covering of water affects what goes on in our daily lives. And this is why we're saying that there is a bit of a problem with climate change. Climate is how the water cycle and associated things are linked together. It basically revolves around the water cycle, our climate. So if we are changing the amount of heat we're either storing in the water or storing in the atmosphere, then we're going to change the way it comes out. Remember, when it comes out, it can be released in rain, but it can also be released in mechanical energy like wind or a kinetic energy form. So this is why we're heading into this, and this is what we want you to think about as you go through. I've tried to simplify it down, and hopefully I have.